Hello everyone, welcome to the AWS PyCharm tutorial series. For this tutorial, we're going to protect our APIs from unauthorized access by creating Lambda Authorizer, formerly known as Custom Authorizer. It is an API gateway feature that uses a Lambda function to control access to your API. First of all, let me remove the authorizers, which I have declared in the template.yaml file. By the way, if you've observed from the beginning, we are using authorizer as none, but we did not set up the default authorizer. If you try to deploy the functions, it's not going to work and it would lead to an error because you haven't set up the authorizer. So let's begin. Let me start by creating an authorizer package under user. I will follow the usual process like creating app.py file. I'll be using an existing blueprint for the authorization process. It's already available in AWS Lambda under the blueprints. I'm going to copy this logic into my app.py. As you can see on my screen, I've successfully copied the logic, but I've slightly refactored the code according to my requirements. You can see line number 23. I'm retrieving the authorization token from the headers. Watch at line 30, I'm calling a method auth_token_decode, which is going to check whether the token is valid or if it has expired. If the token is valid, then the policy is going to allow all HTTP methods, else all methods would be denied. I won't be going into too much detail as the blueprint code is already available in AWS Lambda. For your reference, I will also share the GitHub link of this tutorial. Let's open the template.yaml file where I'm going to define the authorizer under resources. My API is the identifier which we will use as a reference. Type will be a serverless API, which falls under a collection of Amazon API gateway resources and methods that can be invoked through the HTTPS endpoints. Under properties, I'm going to define the stage name. Stage name represents an API stage. You can provide any random text, but the common stage name which is widely used is dev, prod, stage, or test. You will see it appearing in the API gateway URI, Uniform Resource Identifier. Under auth, I will provide a name to my default authorizer. Let me name it as JWT Custom Authorizer. Function ARN is our Lambda function which is handling the authorization process. ARN stands for Amazon Resource Name. It's a naming convention to identify a resource. So JWT auth function is going to process the authorization once we receive the tokens. As usual, we're going to provide the handler, runtime, etc. We're also using an environment variable called secret_key for encoding and decoding our JWT tokens. Okay, we've defined the custom authorizer. Let us now make a reference to each function so each API will only work when a token is provided. As you can see in my screen for the Create User API, I am referring to the custom authorizer through REST API ID. Until then, I have set authorizer as none, which is completely valid. I can exclude APIs for which I don't want an authorizer, for example, like the login API. As I am done with my template.yaml file, let me go to the codebase and create a package for login API. I will follow the standard process that I did for the previous APIs. I'm going to create a token.py file where I will be defining two functions, one for creating a new JWT token, and the other a refresh token, which will be used to generate a new token based on previous token validity until it hasn't expired. I've been talking a lot about JWT and didn't mention exactly what it is. JWT stands for JSON Web Token. It is a self contained way for securely transmitting information between parties as a JSON object. This information can be verified and trusted because it is digitally signed. JWTs can be signed using a secret or a private public key pair. Again, JWT is a standard, meaning that all JWTs are tokens, but not all tokens are JWTs. If you want to get more information about JWT, then I would suggest you visit the website jwt.io. I will also mention the link in the description. As you can see, the function create under access under token, which is going to take the user information and encode it and return us back with a long encrypted string. This token is only valid for 5 minutes. Okay, we're done with the tokens. Let's move to the validator.py file. I'm going to create user login schema in which I will be taking email and password as required input. In the validation function, I will check whether the email provided exists in the database or not. For the password, I will verify with the encrypted password stored in the database. If the password verification is successful, then I will generate a new token and send it back in the response. Then I'm going to create a refresh token schema, which takes the token as required input. If the existing token is valid, then it will return back a new token in the response. Otherwise, it will raise a validation error. Let's move to app.py. I'm going to define the Lambda handler. As you have seen before, I will be parsing the event body and passing it into my schema for validation and post-processing. If the validation is successful, then it will return a token with a 200 HTTP response. Otherwise, it will raise an error with a 400 status code. I will also be defining one more function, token under refresh, in the same file. It is going to perform the same kind of operation, taking an existing token as input and returning it back with a new token. Now I'm going to register the user login and refresh token API in the template.yaml file. We've registered the APIs. Before testing out the API, there are some issues which I have missed. Let me fix that. Open app.py and go to line number 19. It should be load, not loads. Remove the S. Next, I will go to token.py and remove decode in line number 15. And for the refresh token in line number 21, I need to mention the algorithm HS256. Let's test out the functionality. I'll click on Run and then Edit Configurations. You can see I've provided email and password. Let me run the function and check out what response I get. Okay, I'm receiving a new token. Now I'm going to pass this token to the refresh token function, and in return, I will receive a new token. I'm receiving a new token. Both the functions are working great. In the upcoming video, I will be writing unit tests to make sure our functions are working fine before deployment.